Hi everyone, let's do Leetcode 424, longest repeating character replacement. So we're given a string S, which is composed of all uppercase English letters and an integer k. We can choose any character in the string and change it to any other uppercase letter. We can perform this operation at most k times, and we want to find the longest possible substring that contains the same characters. Let's look at this example. So we've got AB, and we've got k equals to 2. We can replace two letters, so it can either be A, and we replace them with two capital B's. And the longest repeating characters here are all B's, so the output is 4. We could also replace the two B's with two capital A's, and we would get the same result. Let's see how to solve this problem using a linear time solution. So one way to solve this problem is to use something called sliding window. So let's say we have a window of size 3 here. There is a simple way that we can check whether one replacement is going to be enough to have the same characters in this substring. So we want to take the length of our window, so in this case is 3, and we want to subtract the occurrence of the most frequent character in this window. So in this case it's B. B is appearing twice, and 3 minus 2 is 1. Now we want to check, is 1 less than or equal to k? Yes, it is. One replacement is going to be enough to make this window have the same characters. So in this case we are going to have 3 B's. So you might be asking, how could we take the frequency of the most frequent letter in the window? And we can use a hash map for that. And here we're using the most frequent ones because the number of replacements is actually limited. So we want to make sure that we're going to substitute only the necessary characters. In this case, A is less frequent, so we want to substitute A. Okay, let's go through a complete example. Here on the right, we've got the formula to see if a window is valid or not. So I'm just going to leave it here. So we're going to need two pointers, left and right. Now we want to update the hash map with the frequency of the characters appearing in this window. In this case is just 1A. We want to take the length of the window, which is 1, subtract the most frequent character, subtract the number of counts for the most frequent character in the window. In this case is 1. The result is 0, which is less than or equal 1. So this is a valid window, and we can update our max so far, which in this case is going to be 1. We are going to now move R, so R is now going to be here. We want to update our hash map with the right frequency, so A is appearing twice. The window length is 2. We want to subtract count of the character that is the most frequent one. In this case it's A. Again, same thing. We want to update max with the new longest character with the same elements. In this case it's 2. R is going to be here. We want to update our hash map. The length is 3, but the most frequent character is still A, so this is going to be 3 minus 2 equals to 1, which is still less or equal to k, which in this case is 1. So is this valid window? Yes, it is. And it's of length 3, so we want to update the max so far. We're going to move R again. We want to update the hash map, so A is equal to 3. The window length is 4 minus the most frequent character, which is still A. This is still going to return as 1, which is still less or equal to K. We are going to update our max so far, which is 4. Now we want to update R again. R is going to be here. We want to update our hash map. So we've got B appearing twice, A 3 times. So we're going to do the same thing. We get the window length, which is 5, minus the most frequent, which is 3. 5 minus 3 is 2, which is actually not a valid window because 2 is greater than 1. What we want to do is move L 1 position. So L is now going to be here. And when we do that, we actually want to also update our hash map. A is now only appearing twice. Now let's actually calculate again if the window is valid. Take the length of the window, which is going to be 4, minus the most frequent one. As you can see, both A and B appear twice, so you can just choose either of them. The result is equal to 2, which is still not valid. So we want to move our L again. L is now going to be here. We want to update our frequency. A is now appearing once. We want to do the same thing now with the new window length, which is 3 minus 2, which is 1. So this is valid. The window length is 3, so it's not greater than 4. We are not going to update our max. We are actually going to move R now by one more position. First, we want to update the hash map now. B is appearing 3 times. We are going to again calculate if the window is valid. 4 minus 3, which is 1, which is valid, but still the max is again 4, which is the same, so we're not going to update our max. We're going to move R by one position here, update the hash map 2, and calculate whether the window is valid. So it's 5 minus 3, which is 2. So this is not valid. We actually want to now move L by one position here, and we want to update the frequency. So in this case, it's going to be 2 and 2. We take the window length, which is 4, minus 2, which is 2. So this is not valid again. We now want to move left again. So left is now going to be here. We want to update the frequency. So in this case, we've got 2 B's and 1 A. I'm going to continue over here. So window length is 3 and the most frequent character is 2. So 3 minus 2 is 1, which is a valid window in this case because it's smaller than K. But the max so far is going to stay unchanged. We can't move R anymore because we have reached the end. So we can return our max, which is 4. And as you can see, it also matches with the output of the example. So this is how this algorithm works. So the time complexity of this algorithm is big O of n, and the memory complexity is constant. So we are using a hash map, but this hash map is going to contain maximum 26 entries because we are only counting the frequency of the letters that are appearing in our string. And as the exercise said, the only possible input characters are capital English letters, which are from A to Z. I hope this was clear. Okay, let's try some code now. The first thing we need is a hash map to count the frequency of the characters appearing in the window. Next thing is a result variable that is going to contain our maximum so far. We need a left pointer, and the right pointer is actually going to go all the way to the end of our input string. We're going to use a 4 for that. Now we want to update our hash map. We take our character as key and then we just add 1 to it. We're going to use get function from Python so we can return a default value when you're first updating this entry. Now we want to check if the window is valid. So we're going to use a while loop, and in order to calculate the length of the window, so we can use right minus left plus 1 minus the frequency of the most frequent character, and we can do it by using the max function. And we want to check if this is greater than K, it means that the window is not valid. So we want to shrink the window. So we're going to move our left pointer by 1 to the right, but before doing that, we actually want to update our hash map with the new frequency. Let's update our hash map. We know that the window is valid again. We want to calculate the maximum so far, and we can simply use the max function. And here we're going to check whether the current window is actually greater than the maximum we already found earlier. So once we have gone through all these operations, we can simply return our result. Okay, let's see if this works. As you can see, it does work. Please like and subscribe if you found this video useful. Thank you.